How can XPS be used to study the nature of molecular structures and atomic valence states in various compounds? What types of qualitative and quantitative analyses can XPS perform on the surface of substances, and how does it provide information about the surface composition? What specific details about the elemental composition of a surface can XPS reveal, and how does it contribute to understanding the coordination structure of the surface? How does XPS allow for the investigation of the surface characteristics of different compounds, and why is this important for material science? In what ways can XPS be combined with other techniques to enhance the study of molecular structures and surface compositions, and what additional insights can be gained through such combinations? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does XPS provide detailed information about the bonding and electronic states of surface atoms, and what advantages does it offer for surface analysis compared to other spectroscopic methods? How does argon ion etching enable the study of electronic, atomic, and elemental information on surfaces, microregions, and depth distributions? In what ways can technological improvements enhance the ability to acquire photoelectron images in a parallel fashion, and what advantages does this offer for surface analysis? How can XPS profiles be obtained from these photoelectron images, and what insights do they provide into the material's surface composition? What is the significance of analyzing the elemental distribution on the surface of a material, and how does this information contribute to the understanding of its properties? How do current advancements in XPS technology facilitate the exploration of not only surface characteristics but also microregions and depth distributions within materials? How does argon ion etching improve the depth sensitivity of XPS measurements? And what impact does this have on our ability to analyze materials with varying levels of surface and subsurface detail? What challenges might arise when studying microregions and depth distributions? And how can these challenges be addressed using current XPS techniques? How does XPS contribute to material characterization, especially when it comes to understanding complex surfaces or multilayered structures? And how do the elemental distributions revealed by this technique influence material design and application? What role does XPS play in advancing research across fields like nanotechnology, material science, and surface engineering, particularly in analyzing the distribution of elements and atomic states within different material layers? What is the binding energy B in XPS, and how is it defined in relation to an atom before and after photoexcitation? Why is the binding energy unique for each element, and how does it reflect the basic properties of the element?